Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Today we are going to present about our project which is car project from group 5. Alright, now let's move to the introduction part. For the introduction, we know that a car project is a tool or device that we use to lift a car. So we can see this tool mostly in workshop or machine shop, even in our spare tire kit. Okay, now let's move to the methodology part. We have 3 steps before we start our project. The first one, we need to use assumption. So in here we assume that our car tool jet only moves vertical direction, and then our car is maximum only 400 km or 4000 Newton for the safety. Okay, next for the boundary condition, we consider that the face of the base always constrained for all the degree of freedom. Okay, now let's move to the last part of methodology, which is our material choose. We choose AISI 4340 known as hard strength steel. Why we choose this material? Because resistant to wear and tear, and next resistant to atmosphere corrosion, and the last one is formability, machinability, and heat treatability of this material. When we use car screwjack as our project, so we consider there are 3 crucial parts, which is the top and the links, also for the bottom base. And now I will show the videos how we simulate this our car screwjack for the color design, and the next part is our simulation for the new design.
My name is Duboy and my metric number is MH19047. I'm going to talk about the new model design. So this we spread the gear parts of the upper and the lower arms to strengthen the gear system. The arm stay part is modified to have a chamfering and the short opening. It can show in this figure. This is the AD drawing of each part. It's the lower left arm, lower right arm, upper left arm, upper right arm, left pad. So for the analysis, we are going to put a lot of car on this left pad on the jack, and then we will analyze the left pad. We have put 1,000 pounds total load on here. This can show in this figure. Then run a simulation is bending this area down there. It's showing this figure. Finally, we do a dynamic simulation with motion load analysis. We would have to put out a motion load for each of these compression at different time steps. That's all. Thank you.
Good day, sir. My name is Sun Ming Hong and my matrix number is MH19041. So I will be presenting about the result and discussion part. So for our project, the three parts that we have chosen is bottom base, link, and also top. So for your information, all those three parts, the changes in the bond resistance stress, displacement, and strength, all these three components has increased for the new design compared to the old design. So here is our data, as you can see from the table, and here for the top, whereas for the link. So for this part, it can show that all the bond resistance stress, displacement, and also strength for the new design has increases compared for the old design. So here is the deformation of our new design and conclusion. So conclusion, AISI 4340 engineering steel is selected, and more study was done to find the ideal specs for the item to be considered using Autodesk Inventor Nasrat. So as a result of the study, each of the 5 components has its own consistency in terms of value inside the parts, and this shows that when we apply a lot and limits to it, each component suffers specific stress, strength, and displacement. Thank you. That's all from me.